Now, continuing with the element compounds mixture, we have already done solid-solid mixture. The separation we have seen it in the solid-solid mixture, the different types of separation, that is hand picking, magnetic separation. Then we have seen using a suitable solvent, then fractional crystallization, and what more we have seen? Gravity separation. We have seen it. All these type of separation we have seen it. Now, out of that, the using of suitable solvent is very, very important, children. So, read properly that particular one. Next, we will come under solid liquid mixture. Under solid liquid mixture, we are having sedimentation, decantation, filtration. Now, you know what is sedimentation. Sedimentation means, let me give an example to you. Suppose you take a muddy water in a beaker and allow the mud to settle down. Alright. After some time, you will see the mud or the clay will settle down at the bottom. That is said to be as sedimentation. Bottom means bottom of the beaker. That is called, that phenomena, that process is called sedimentation. We can say that. Now, after that, you just pour the liquid which is there above the sediment, the clear liquid. Of course, not absolutely clear, little bit clear, you can say that. That is known as a clear supernatant liquid. What you do is that you pour it with the help of a glass rod, very, very slowly without disturbing the sediment. Without disturbing the sediment, you pour it very, very slowly with the help of a glass rod. You put a beaker here. Alright, and by the help of a glass rod, you pour it very, very slowly. You will see that, but remember it, you did not have to disturb the sediment. Sediment, you are not going to disturb it. Sediment will remain as it is. So you will see it that the clear supernatant liquid will come out in another beaker without disturbing the sediment. The sediment will remain in that beaker as it is. But the process has to be very, very slow. And by the help of a glass rod, we take a beaker in this way and you put a glass rod there, and by the help of the glass rod, you pour it, the clear supernatant liquid. So that is called as decantation. That is known as decantation. But as I said you, by the help of decantation, you don't get a clear liquid. Absolutely clear liquid, you won't get it. You will be getting a translucent, not a transparent liquid, a translucent. You will see some particles also floating there or whatever it is. Clear? Now, what you need to do is that you will take this particular liquid and you go for filtration. You go for filtration. Alright, you take a, that is nothing but this flask, or you take a beaker, whatever it is. You take a funnel, you fold a filter paper, alright, into a cone shaped, and you wet the surface of the funnel. Alright, you wet the surface of the funnel, then you put the filter paper into it. Alright, then all the filter paper will stick to the funnel. Now you pour that clear supernatant liquid into that filter paper which is there in the funnel, and below the funnel you keep it a beaker to collect the liquid. You will see a clean, clear liquid will be collected at the bottom of the, what you can say, in the beaker it will be collected. That is nothing but known as a filtrate. And you will see some substance will be remaining behind on the filter paper. That is called as a residue. If you find that still the liquid is not clear, once again you can go for filtration. Twice you can do the filtration till you get a clear liquid. So this is known as filtration. We can say that. All of you know this particular thing. But it's not a new thing for you. So in this way, while doing sedimentation, the what you can say, the mud or the clay or whatever it is, the muddy water I mean to say, which settles down at the bottom, the heavier particles will settle down at the bottom. That is called as a sediment. Alright, and the liquid which settles at the top, that is called as a clear supernatant liquid. So it is known as a clear supernatant liquid. Alright, generally the sediment which settles down at the bottom, that is called as nothing but known as a suspension. Already we have talked to you earlier. That is known as a suspension. That is said to be as suspended particles. Alright, now in this way we go for decantation, sedimentation, decantation and filtration, we can say we go for. Now the advantages over filtration is that, over sedimentation, decantation is that by the filtration we get the clear liquid, and we are completely separating the sediment from that of the liquid. We are completely separating, that is, we are completely separating the liquid from that of the solid. We can say that completely. That can be done by the help of filtration. But by sedimentation, decantation, it is not possible. We can say that. Now, completely we cannot separate it. And moreover, it is a quicker method. Method is very quickly. What in your house we are using now? That is filters we are using. It isn't AquaGuard, Kent Vent we are using it. What is being done? Filtration is being done. It's a very quick process, we can say that. Clear? Now, next, after that, we'll go for centrifugation. Centrifugation. Now, centrifugation, generally where it is being done? It is being done to separate the blood from the plasma. It is being done to separate the cream from the milk, we can say that. Clear? How do we do it? Now, think of, these are the two test tubes. Alright, these are the two test tubes. Alright, think of, these are two test tubes. This is the open end of the two test tubes. Now we will put the blood in one of the what you can say, test tube, will put it, and we will join the mouth of the two test tube in this way. We'll join it, and we will rotate this test tube by help of a centrifugal machine at a very high speed. We'll rotate the test tube. It is going to rotate in this way. Alright, at a very high speed is going to rotate. By doing so, what will happen is that the plasma is being separated from the, what you can say, the formed elements. Alright, in one side you will get the plasma, other side you will be getting the formed elements. Formed elements, you know, RBC, WBC and the platelets you will be getting in another sides. Alright, so this is known as centrifugation. Similarly, you can take milk, and if you want to separate the cream from that of the milk, that you can do it for centrifugation. You just take the milk in one of the test tube, rotate it at a very high speed. You will see after some time the cream is being separated from the milk. The milk is in one test tube and the cream is in other. So this is known as centrifugation, we can say that. Clear? So basically it is used in dairies industries. Alright, because in earlier days we used to go for centrifugation, but that is called churning, isn't it? Still in some houses they are churning in this way the milk to separate the cream from that of the milk. Alright, we are using in some houses. That is a mechanical method, very tedious method. Alright, and in industries it cannot be done, isn't it? So dairy industries, the process has to be fast. Clear? That is the cream from the milk we need to separate. So hence we go for centrifugation. This technique we go it and we separate it. That is called centrifugation, we can say that. The technique is sometimes used instead of filtration when some quantities, small quantities of material are used. We can say that small quantity of material like blood, milk and all those things, it is being done. Alright, but in dairy industries, the centrifugation which we use it's a big machine, we can say that. Here just I tell you a test tube, isn't it? A process I told you, got it? Don't think that in the industries also test tube is used, not at all, isn't it? Not at all possible. Alright, fine. The next is evaporation. Now evaporation is the process of changing a liquid into its vapors below its boiling point. Alright, by supply of heat from an external source. When you are heating a particular substance, it evaporates. A liquid, it evaporates, isn't it? But below its boiling point, you have to heat it, then only it's going to evaporate. Alright, clear? For example, you are having a mixture of sodium chloride and water, salt and water. You want to separate it. How do you do that? You just evaporate it. Salt will remain behind, water is going to evaporate. Alright, you are going to supply a heat, or you can keep it outside also. It is going to absorb the sun's heat, the solar energy. Or you can heat it in a Bunsen burner, or in a, what you can say, in a burner you can heat it, but slowly. Slow heating has to be done. Alright, so that water is going to evaporate, leaving behind the salt, we can say that. Clear? So this method is used to separate the solid from that of the liquid, we can say that. But one thing is important here, that liquid is lost permanently. You are not able to collect the liquid. If you need to collect the liquid, then you have to go for, that is nothing but known as, what is that? We have to go for, that is distillation. That is a drawback of the evaporation process. That in case of evaporation, liquid is separated from the solid, no doubt, but we are not able to collect the liquid. If you need to collect the liquid as well as the solid, then we have to go for distillation. In the distillation flask, we need to do this particular one. So that is generally evaporation, which particular kind of substances we do it, like salt water, sugar water, then sulfur and carbon disulfide, iodine and chloroform, because iodine dissolves in chloroform, sulfur dissolves in carbon disulfide, sugar dissolves in ethyl alcohol. So in this way, you are going to take a mixture of sugar and ethyl alcohol, you will be heating it, sugar will be remaining behind and ethyl alcohol will evaporate. Alright, but you have to heat it below its boiling point, remember it. Alright, clear? So this is evaporation, we can say that. Now what I said you, in distillation, what you do is that you do the same thing, but here the non-volatile component is what you can say is the volatile component is not lost, and the non-volatile component also we are getting it back at the same time. Alright, but the things you have to remember is that here it is, it should not be a highly inflammable liquid. Alright, highly inflammable, because otherwise it will catch fire. Alright, you need to remember that. The liquid should not be highly inflammable, it should not catch fire. Alright, and in case of high boiling point liquid, the flask is heated directly with the flame. Because if it's a high boiling point liquid, means indirectly you cannot use. Generally what we do, we take a tripod stand, we put a wire gauze above it, and we put the substance, that is a flask or the beaker, we put it, and then we put this mixture and we heat it. But if it is a high boiling point liquid, then you have to heat it directly with the help of the flame, because high boiling point, you have to heat it directly, so that the heat will be maximum in that particular case. Now distillation, you know it, in case of distillation what happens is that when you will be taking the liquid, then the water, the volatile substance, that is the generally water, we can say that it is volatile, or ethyl alcohol or carbon disulfide, whichever you've taken it, that will pass through the Liebig's condenser, and there it will be collected as a distillate in the form of liquid, and the substance, the non-volatile substance, will remain behind in the flask. We can say that the non-volatile substance will remain behind in the flask. Alright, clear? So this is known as distillation, we can say. For example, salt water, if you take it, then salt will remain behind in the flask and water will be collected as a distillate. Alright, because water will vaporize out, and that vapor will pass to the Liebig's condenser. There it is, the vapor is being allowed to cool down, and it gets converted into liquid water, and the water is collected as a distillate, we can say that. And the sand remains as a salt remains as a residue, we can say that. Clear? In this way, that is known as your distillation, we can say that. Similarly, we are also having fractional distillation, we can say fractional distillation. Now generally, fractional distillation, what is that? It's a process of separating two or more miscible liquids by distillation, by making use of their boiling point, the difference in their boiling point. That is very, very important. Alright, what I said, fractional distillation. Alright, in fractional distillation, the liquid should be miscible in nature. Alright, so here we come to separation of liquid-liquid mixture. Till now I was talking to you about solid-liquid mixture, where I said sedimentation, decantation, filtration, and distillation, evaporation, I said all these things. Now here, in case of fractional distillation, what you need to do, what we'll do is that here we'll be using, that is, so let us say we are using this flask, and here you'll be using a fractionating column. Alright, this sort of fractionating column you will be using it. This sort of fractionating column. Let me draw it properly. A fractionating column you will be using. Clear? This will be connected to Liebig's condenser, and after that it will be connected. This is your Liebig's condenser will be there, and it will be collected here in a beaker. You will be getting it. Alright, so this is a rough diagram I've done it. It's not a fair diagram. Understood? It's a rough diagram I'm saying you. Rough diagram I've done it here. It's not a fair one, minded children, because I need to explain you the process. Here diagram is not important. Here you need to understand the process, that is important. Alright, so this is a fractionating column, as you can see it here. So here I will be taking the liquids. It will be two miscible liquid. Mind it. Here, that is, I am going to take it two miscible liquid. Of course, a cork will be here. Alright, fine. Now, generally this method is used to separate two miscible liquids, because till now I was doing solid liquid mixture. Now it is liquid mixture. Two miscible liquid means ethyl alcohol and water. Alright. Then acetone and water. Then methyl alcohol and ethyl alcohol. Acetone, ethyl alcohol, benzene, toluene, liquid oxygen, liquid nitrogen. So many, you can say that. The liquid should be miscible, mind it. The two components should be miscible. And the difference in the boiling point should be at least 10 degrees Celsius. The difference in boiling point should be at least between the two components. Like suppose you have taken ethyl alcohol and water. Na? The difference in the boiling point between ethyl alcohol and water should be at least 10 degrees. At least, minimum. Why? If it is less than 10 degrees, what will happen? Both will volatilize out. Water will also volatilize out. Ethyl alcohol will also volatilize out. And it will be collected here. Then how will you separate it? That cannot be done by fractional distillation. For example, ethyl alcohol and water, if you are taking it, the boiling point of ethyl alcohol is 78 degrees centigrade and water is 100 degrees centigrade. So there is a difference of 22 degrees Celsius. Mind it here. So it can be done. Acetone and water, if you take it, acetone, the boiling point is around 56 to 57 degrees Celsius and water is 100 degrees Celsius. Large difference in boiling point. Similarly, methyl alcohol and ethyl alcohol, if you take it, ethyl alcohol is said you just now 78 and methyl alcohol is around 65 degrees Celsius, we can say that. So in this way, there should be a difference in boiling point should be at least 10 degrees Celsius. At least, mind it, and it should be miscible liquid. Alright, so you'll be taking here the two liquids and you'll be heating it from below. You'll be heating it from below. Got it? So on heating, what will happen is that the volatile component will pass through it. Got it? And it will be collected here. Volatile component means suppose you are taking ethyl alcohol and water. So which is volatile? The one which is having low boiling point. So ethyl alcohol is 78 degrees centigrade, so it is having low boiling point. So ethyl alcohol will pass through it and it will be collected here, because here the Liebig's condenser will be there. In the Liebig's condenser, this what will happen is that, you know, Liebig's condenser what it is, the cold water is passing through and the hot water is coming out from this. We are having an inlet and we are having an outlet for the hot water, we can say that. Clear? So in this way, what you will find is that here the vapor will turn into the liquid state and the liquid will be collected here. That is the ethyl alcohol will be collected here and water will be remaining behind. Now, won't you say that, sir, will not water will go out of it? Yes, water will also go along with ethyl alcohol. It will also form vapors after some time. Alright, but the water vapor will be what you can say, what I should say, that it will be obstructed here. It will not be allowed to pass through this distillation, what you can say, this flask. It will not be allowed to pass the fractionating column, not distillation flask, the fractionating column. The fractionating column will trap the, what you can say, this water molecule. It will trap the water molecule. As a result, the water molecule will remain behind. It will come back. And the ethyl alcohol molecule, which is more volatile than water, will pass through, and this ethyl alcohol vapors will get condensed here and the condensed liquid will be collected here. So you will get ethyl alcohol here and will get water here. Understood here? The more volatile component, the component which is having low boiling point, that is said to be as volatile. Alright, so as I said you, ethyl alcohol is 78 degrees Celsius. It is having low boiling point. It will pass through this fractionating column. It will get what you can say, the vapor is going to get condensed here and the liquid is going to get collected here. And the water which is having, it is less volatile in nature compared to ethyl alcohol. It will be trapped by this fractionating column and it will come down and it will be collected here. In this way, we can separate the two miscible liquid. Basically, this process is being done to separate two miscible liquids having difference in their boiling point. We can say that. Clear? And for that particular purpose, to trap the non-volatile component, we have used a fractionating column. In this way, number of fractions we can use it. So more number of fractions, more what you can say, the liquid can be trapped and it can be brought down. We can say that. Clear? Fine. In this way. Now next is that is we will be going for separating funnel. Another one is, it is basically it's done to separate two liquids which are immiscible. Mind it. Here I was talking miscible liquid. Here two immiscible liquid but differing in densities. Differing in densities, we are having a fractionating column. Fractionating column is a very easy one. You can say that this is a fractionating column. We can say, clear. Here we will be collecting it. So suppose I will be taking a mixture of oil and water. Oil and water. So you will be getting oil at the top because oil is lighter than water. You will be getting oil at the top and water will be collected below. Alright. Water you can see here, this black one I have made it as water. Water will be collected below. Here a stopcock will be there. Stopcock. I'll open the stopcock and I will allow all the water to drain out. Here, all the water will be drained out here. Slowly. The process has to be done slowly. Alright. So when all the water will come out here, all the water is going to come out here, then what will be remaining here? Alright. When all the water comes out here, then what will be remaining? Only oil will be remaining. That's it. In this way, you can separate two immiscible liquid by using separating funnel. This is on a separating funnel. But remember it, the liquid should be immiscible and it should differ in densities. As I have taken oil and water, so oil is lighter than water, so oil is going to float upon water. Alright, and hence we can separate the two immiscible liquid. You can say that. Similarly, we can also separate carbon tetrachloride and water. You can separate benzene and water. You can separate toluene and that is nothing but carbon tetrachloride. We can say that. Clear? In this way, two immiscible but differing in densities. We can say that. So that can be separated by using separating funnel. So this is a technique which is being done to separate two immiscible liquid differing in their densities. Alright, mind it? So in this way we have done today, that is solid-solid mixture, we have done solid-liquid mixture, and we have also completed liquid-liquid mixture. Little bit is more is left, we will do in the next video. Thank you.